Assalamualaikum warahmatullahi wabarakatuh. Hello everyone. Here we will explain about the classic assumption test using SPSS, where we will explain the results of processing questionnaire data. Okay, next. Before that, allow me to introduce the team's member. There sits Asia Asih with last digit name 156, Adhek Faza RA with last digit name 159, Adinda Naela 165, Mawar Aprilia 168, Lintang Alya 174, Asischa Putri 192, Livia Alzena 205, and me, myself, Rafaellia Narayan with last digit name 214. 214. Next.
Background: the classical assumption test is an important step in linear regression analysis, especially to ensure that the model used is valid and reliable. Without conducting a classical assumption test, the result of the regression analysis may lead to incorrect conclusion. By conducting a classical assumption test, it can increase the credibility of the research. Researchers who pay attention to and report the result of the classical assumption test so that they have taken the necessary steps to ensure the integrity of their data and analysis result. The purpose of a classical assumption test aims to ensure that the resulting regression model has precision in estimation, so that the resulting estimates are accurate and unbiased. Next. The total sample is 209 respondents. Data collection period is not mentioned. Variable dependent or Y, TEA, and variable independent X, TKP, TEG, TKI, TPB, TSN, TKW. Next. And this is the research method. Next.
And next is normality test. What is normality test? Normality test is about with the aim of assessing the distribution of data in a group of data or variables, whether the data distribution is normal distributed or not. Data that is more than 30 can be assumed to be normally distributed, usually said to be a large sample.
Okay, then is step by step from normality test. First, in the file of type selection, select Excel and press the file you want. And next, second, select the sheet in your Excel where the data is located. Third, when the data appears like in Excel, please click on the variable view in the left corner there. Fourth, next, take the total data in each questionnaire and in the measure section, click the data and make it scale. Fifth, after it has been changed to scale the entire total questionnaire data, then click Analyze and then Regression and continue to click Linear. Next. And 6. Input the total data in the independent as X. Expect the total of the last data is charged as Y data. 7. Because the last data is Y, then it will be inserted into the dependent part. Next. 8. After that, click Statistic in the right corner and several elements will appear, and then check the Estimate Model Fit and Collinearity Diagnosis. 9. After the Statistical section is click OK, then in the Plot section, click ZPRET on X and SRESET on Y, as well as check the histogram and normal probability plot, and if you have, click Continue. Next. And then in the subsection, click Understand the result, and if so, continue. In 11, after which the result appear on the output. Next. On 12, if the histogram diagram is the middle shape of the high open downwards, then the data results are declared normal. Next. On the 13, the results are also declared normal from the normal p-plot line where it states normal. Next. 14. To strengthen the statement of the normality test, which usually if more than 0.05 is declared normal, then we will click on the RES1 section. 15. After that, click Analyze followed by clicking Leak Dialogues if you have clicked 19 sample K2S. Next. 16. If it appears like an clicking, it will appear in the SPSS output in PRR test at point states this distribution is normal. Can also be seen in the same section. There then result how 0.10, so it is more than 0.05. Next.
Okay, now is the test result of normality. Based on the significance value of the key S test, which is greater than 0.05, as well as the support from the histogram and p-plot, it can be concluded that the regression model residuals follow a normal distribution. This indicates that the assumption of residual normality has been met, so that the result of the regression analysis can be interpreted with a higher level of confidence. If you want to know more, please read it yourself. Next.
So next is multicollinearity test. And what is that? Multicollinearity test is a test conducted to ascertain whether in a regression model there is intercorrelation.
So this is a step-by-step from multicollinearity test. The first one, input data from Excel to SPPS like before. And second, click the Analyze menu, then click the Regression menu, and then select data, the linear menu. Next. And third, click Move X1, X2, X3, X4, X5, X6 data from block 1 of 1, and then move Y data to dependent, then click the statistic menu. And four, click the collinearity diagnostic, and then click Continue and click OK. Next. And the last one, the data from the multicollinearity test is now visible. Next. This is the multicollinearity test result. Based on the requested the tolerance regression model in the data free from multicollinearity problem, the strength, the accuracy, the regression model, because there are no independent interpreter, and the analysis result will be more reliable. So the multicollinearity summary is tolerance value more than 0.10 and VIF value less than 10. For each independent variable, it can be concluded that the regression model in the data is free from multicollinearity problems. Next.
So next we have autocorrelation test. What is autocorrelation test? Autocorrelation test is a test that analyzes the assumptions of the regression, which consists of testing the effect of the independent variable on the dependent variable, so that there should be no correlation between observations and previous observation data. Next.
For the first, open the SPSS one in the file of type section, select Excel, and press the file you want. Next. Second, select the sheet in the Excel where the data is located. Third, when the data appears, like in Excel, please click on the variable view in the left corner. Next. 4. Convert all columns to scale. 5. After moving the data to the department in and independent columns, after that, step 1, tap the column that says statistic. Step 2, after that, the table comes out linear regression statistic. Step 3, do according to the number in the picture. After finishing, press continue. Step 4, after continue, click OK and the data is ready. Next. The conclusion from the autocorrelation test result show that the regression models used has an R value of 0.719 and R square of 0.517, which means that about 51.7% of the variation in the department variable TEI can be explained by the independent variables TKW, TKP, TKI, TSN, TED, TPB. The ANOVA test show the significance of the model with an F value of 39.031 and a P value less 0.0001, indicating that the overall model is significant. The TPB, TSN, and TKW variables have a significant influence on TEI with a value of less 0.0001 each. Next.
So next we have heteroscedasticity test. Heteroscedasticity test is a regression model test tool to determine the inequality of variance from the residuals of one observation to another. If the variance of the residuals from one observation to another is constant, it is called homoscedasticity, and if it's different, it's called heteroscedasticity. Next.
Yes, step-by-step heteroscedasticity test. First, click transform, then click compute variable. And second, in the target variable column, change it to ABS underscore S. After that, click on the function group column in the arithmetic section. Then in the column at the bottom of the function group, click ABS to double click so that in the numeric section, the words ABS underscore S will appear. Third, back in the data view, click Analyze, then Regression and Linear. Fourth, return to the data view, then remove the unstandard value in the dependent column and replace it with ABS res 1. Click Save, then the table and column appear. Let's click to uncheck the unstandardized section. Click Continue and OK. And the result heteroscedasticity test, interpretation of value for of 0.05. Second, if the value of Z less than 0.05, then there is no heteroscedasticity in the variable. The model fulfills the assumption of homoscedasticity. And third, if the value of Z less than 0.05, then there is indication of heteroscedasticity in that variable. The models does not meet the ion of assumption homoscedasticity. In the result table, those with a significance value of more than 0.0 are TKB, TID, TKI, TSN, and TKW, meaning that these variables do not occur symptoms of heteroscedasticity. Meanwhile, for the independent variable TPB, whose significance value is less than 0.05, this variable has heteroscedasticity symptoms.
Next is linearity test. What is linearity test? Linearity test is a test tool needed to determine the form of relationship that occurs between the variables being studied. This test is conducted to see the relationship between the two variables that have been studied, whether there is linear or significant relationship.
Next, I will explain step by step how to conduct a linearity test in the SPSS application. In the step 1, before starting the test, we need to import an Excel file into SPSS. The method is shown in the image. Select File, then click Open and Data, then import the Excel file that will be tested for linearity. For the second step, change files of the type Excel in order to find the Excel file that will be tested for linearity. Next. The third step, click Variable View to change the measure data with names containing the letter T to scale. In the first step, to test the data, click on Analyze, then go to Compare Means and select Mean section. Next. In the fifth step, enter the data in each table for the data TKP, TAD, TKI, TPB, TSN, and TKW. Input this into the independent list, while the data TAI should be entered into the dependent list. After that, click on Option. In the sixth step, after clicking Option, the display below will appear. Check box for test for linearity and then click Continue. Next. In the seventh step, after that, a dialog box will appear. Click OK to run the analysis. In the eighth step, after running the analysis, the result of the data linearity test will appear. The next part will be explained by my friend.
Okay, linearity test data result. As you can read it yourself here, so if the SIC is more than 0.05, there's no significant deviation from linearity, meaning that the relationship between the independent and dependent variables can be considered as linear. If SIC is less than 0.05, there is a significant deviation from linearity, indicating that the relationship between variable is not completely linear. This suggests that a linear regression model may not be appropriate. Next. Measure of association indicates that the strength of the relationship between the independent and dependent variables using metrics such as eta squared. A high eta squared value indicates a strong relationship supporting the assumption of linearity, while a low value indicates that the independent variable may not significantly influence the dependent variable, suggesting that an alternative model or approach may be required. Here you can see yourself the ANOVA table. All data results that have been tested for linearity show that the test results are linear, except for the result of the relationship test between TEI and TKI. The deviation from linearity value shows 0.000, where it is less than 0.05.
Okay, I think that was an explanation of the classic assumption test using SPSS. More or less, we applied it profusely. So I think thank you for your attention and your listening. Wassalamualaikum warahmatullahi wabarakatuh.